Okay, then relative position of the data. So from Khan Academy, you also learned about quartiles, and I'm also going to talk about percentiles. What is a percentile? Definition. Given an observed value x in the data set, x is the pth percentile of the data if the percentage of the data that are less than or equal to x is p. The number p is the percentile rank of x. So what does that mean? You have to look at an example. So the data is written in increasing order. What is this? This is the GPAs of some students. So there was one student. Generally, there are how many students? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. And these are their GPAs. So 1.39, 1.76, 1.9, 2.12, 2.53, 2.71, 3, 3.33, 3.71, and 4. So these are the GPAs of 10 students. Yes, students. What percentage of the data are less than or equal to this number? There are 10 numbers, and there is only one number that is less than or equal to this. So this would be the 10th percentile. How many numbers are less than or equal to 1.76? 2 numbers. That's 2 over 10. 2 over 10 is 20%. So this is the 20th percentile. How many numbers are less than or equal to this number? 1, 2, 3, 4, 5, 6. 6 out of 10, which is the same thing as 60%. So the 2.71 is the 60th percentile of the data. Does that make sense? So that's the meaning of this. Given an observed value x in a data set, x is the pth percentile of the data if the percentage of the data that is less than or equal to x is p. So let's take a look at another example. Imagine we have, let's say, ages of 8 students. 18, 19, 19, 20, 21, 22, 22, 1, 2, 3, 4, 5, 6, 7, and 25. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So imagine you have, this is the ages of 8 students in a class. And you are looking for, you want to calculate the percentiles. 18 is the 1 over 8 percentile. 19 would be 3 over 8 percentile. 20 would be 4 over 8 percentile. Because look, for 19, the question is how many students they have an age less than or equal to 19? 3. Yes? And then 21 would be the 5 over 8 percentile. 22 would be the 7 over 8 percentile. And the last one would be 8 over 8 percentile. So the last number is actually the same as the 100ths, because 1 over 8 over 8 is 1, which is 100%. Percentile. Make sense? Or this number here, if I divide 5 by 8, divided by 8, so this is equal 0.62.5. So this is the 62.5th percentile. Is it clear? Now there are 2 percentiles, 3 percentiles that are very important. They're called quartiles. Yes. What are the quartiles? The quartiles are Q1, which is the 25th percentile. You have the second quartile, which is the 50th percentile, which is the same as the median. And we have the third quartile, which is the 75th percentile. Q1 is so that 25% of the data are less than or equal to Q1. So 25% of data are less than or equal to Q1. And then automatically 75% are more. Q2 is the median. So half of the data are less than Q2 and the other half are greater than Q2. And Q3 is so that 75% of the data are less than Q3. So 75% of data are less than or equal to Q3. And you know that if you do Q3 minus Q1, you get something called interquartile range, which is a measure of variety. If you have data with a bigger interquartile range, then the data has more variety. If the interquartile range is smaller, then you have less variety. So here you have the definition for the 3 quartiles, and I'm going to show you how to calculate these quartiles. So imagine for these numbers, you want to calculate the quartiles. Yes. Q2 is very easy because that's the median. Yes, you're just looking for the middle number. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in order. If you have 10 numbers in order, then there is no median. Yes, 1, 2, 3, 4, 5. There is no middle number. So this would be the middle of the numbers. Yes. So you have to take the average of these two. That would be your Q2. It's the median. 2.53 plus 2.71. You add them up and you divide by 2, and you're going to get 2.62. That's your Q2. Now, how do you get your Q1 and Q3? You can think of Q1 as the middle of the first half. So 1, 2, 3, 4, 5. Just divide this into 2 halves. Find the median of the first half. The median of the first half is going to be the middle number here. So that's your Q1, 1.9. And the second half has also a middle number that's here. That would be Q3, 3.33. Make sense? If you have an odd number, for example, if you have 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have 9 numbers, then here would be the median, and then the middle of the first half and the middle of the second half would be the Q1 and the Q2. So Q1 would be the average of these two measures, and Q3 would be the average of these two measures. Make sense? Any questions? You also have more examples here. That's a box plot. You are already familiar with that. The minimum, these are called whiskers. The maximum, Q1, Q2, Q3. The interquartile range, which is a measure of dispersion or variety. Next is the z-score. Z-score is also explained here. That's for modeling data distributions. You're going to learn about percentiles and z-scores in modeling data distributions, which is due on December 5th. That's the formula for the z-score. This formula is used for the sample, and this formula is used for the population. Yes. So if you have the population, then you have the population mean and you have the population standard deviation. But if you don't have the population, if you only have a sample, then you have the sample mean and the sample standard deviation. For any measurement, you can do minus the mean and divide by a standard deviation, and then you have something called the z-score, which is a standard score. It's used for comparing data. So that's the formula for the z-score. Yeah, I think I'm going to explain more about the z-score next class.